Oh, hey, I didn't know you were joining us at the Tellus Science Museum today. I was just telling the boys, imagine this. Your spaceship lands. You step outside with nothing but a picnic basket. No helmet, no oxygen tank, no magic button to not explode. Just beautiful blue skies, soft green grass, and a stream nearby.
Does a place like that exist in the universe?
If it did, that would be way cool and change everything. So let me tell you a story about why finding another Earth is a lot harder than it sounds. Follow me.
So first, yes, we have found a ridiculous number of planets outside our solar system. They're called exoplanets, planets orbiting stars that aren't our sun. Currently, NASA lists over 6,000 confirmed exoplanets. That's not a typo. There are actually 6,065 confirmed exoplanets, and that number keeps growing as our telescopes get better. But, big but, finding a planet is not the same thing as finding a planet you can live on. Finding a planet is like seeing a single crumb on the kitchen floor and shouting, "We have confirmed there was cake." So, how do we even detect these planets in the first place if we can't usually see them directly? The most common method is called the transit method. A transit happens when a planet passes in front of its star from our point of view and blocks a tiny bit of the star's light, so the star looks like it dims on a schedule. Think of it like this. You're watching a bright lamp and a bug flies in front of it. For a moment, blink, the light dips. Do it again, blink, again. If the dimming repeats regularly, scientists go, something is orbiting that star. Now, here's the catch. Small planets block less light. Big planets block more light. So we tend to find big planets more easily. Which means, brace yourself, our planet hunting methods are kind of biased. It's like trying to count ants by looking for footsteps. You'll mostly find elephants, and that bias tricks us into thinking other solar systems look totally different from ours. But there's a twist coming. When people say, "Is there another Earth?" they usually mean one of two things. The first is a world where humans could step out with no special gear and have a normal day. The other is Earth-ish Earth, a planet that's rocky, not a gas giant, around Earth size and in the star's habitable zone. The habitable zone is the not too hot, not too cold region where liquid water could exist, at least in theory. Now you might think, okay, cool, find Earth-sized planets in the habitable zone. Done. Not so fast, because habitable zone doesn't mean habitable. It means the temperature might allow liquid water if other things are right. And the universe loves the words, if other things are right. In a minute, I'm going to introduce you to the biggest Earth imposter in our solar system, one that technically fits the basic checklist, but would absolutely ruin your picnic. But first, let's talk about planet building because it matters. When solar systems form, you start with dust and gas swirling around a baby star. Little bits clump together, clumps collide, bigger clumps start vacuuming up smaller clumps. This is called accretion, basically the cosmic version of making a snowball by rolling it downhill. Here's a simple rule of thumb from planet formation. If a planet gets big enough, it can start grabbing lots of gas. And farther from the star, it's easier to keep gas in ices. That's one reason our solar system looks like this. Small rocky planets close in, like Mercury, Venus, Earth, and Mars, and big gas ice giants far out, like Jupiter, Saturn, Uranus, and Neptune. So, you'd think, if it's Earth size and in the habitable zone, it's probably rocky. And sometimes that's true. But sometimes, solar systems play by the same basic rules and still produce setups that look like someone spilled planets onto a table and went, perfect, no notes. In many solar systems we've observed, it's common to find planets bigger than Earth orbiting closer to their star than Mercury is to our sun. Some systems even have Jupiter-sized planets extremely close to their stars, often nicknamed as hot Jupiters. Meanwhile, in our solar system, Jupiter is way out there, taking nearly 12 years to orbit the Sun. So, are we the weird ones? Maybe. Or maybe we're just hard to detect. Because, remember, the transit method. Small planets means harder to detect. Planets far from their stars means fewer transits. If an alien civilization tried to detect our Jupiter using transits, they might need to watch our Sun for up to 12 years to catch enough repeated dips to be confident. Saturn would take even longer, around 30 years to repeat enough patterns. So, a solar system like ours might be hiding in plain sight, just like a shy kid in a dark hoodie at the back of the class. Still there, just not raising its hand. Now for the Earth imposter, a planet that's similar in size, kind of in the habitable zone neighborhood, and still a total nightmare. Let's talk about Venus. If you only look at size and neighborhood, Venus can seem Earthish. It's rocky, it's close in size to Earth, it's not that far from the habitable zone region depending on how you define the edges. But Venus is basically what happens when a planet says, I'm going to speedrun becoming unlivable. Venus's surface temperature is around 465 to 467 degrees Celsius, hot enough to melt lead. Its atmosphere is mostly carbon dioxide, about 96.5%, and the air pressure at the surface is about 92 times Earth's. Any surface water it had is long gone. So Venus is proof that distance from a star is not the whole story. A planet can be in the zone and still be a disaster because of its atmosphere, chemistry, history, and geology. And here's the spooky part. Some scientists think Venus might have been more Earth-like a very long time ago, before it turned into the ultimate cautionary tale. So when we hear 60 possible Earth-like worlds, what does this actually mean? And what don't we know yet? Scientists sometimes make a list of potentially habitable planets, usually meaning roughly Earth-size, possibly rocky, in the habitable zone. Here's the important idea for us. Even when a planet is the right size, we still may not know what it's made of. Only a small number of these candidates have been confirmed as rocky with high confidence. Because measuring composition is hard. A planet could be a rocky world like Earth, a watery, heavy ocean world, a mini Neptune with thick gas layers, or something we haven't even categorized well yet. Same size doesn't always mean same type. It's like seeing two wrapped presents that are the same size and guessing they're both a basketball. One might be a basketball, the other might be 400 pairs of socks. So, how do we go from we think it exists to we know what the air is like? That's the next frontier. If we ever want to answer the picnic basket version of the question, we need to know what's in the atmosphere, because atmosphere decides a lot. Temperature and greenhouse effect, surface pressure, whether liquid water can survive, and whether you can breathe without instantly regretting being born. Scientists use techniques like spectroscopy, which is breaking starlight into a rainbow to look for chemical fingerprints when a planet transits its star. That can hint at gases like water vapor, carbon dioxide, methane, and oxygen, which can be very tricky to interpret. Now, important science moment. Finding a gas is not the same as finding life, but it helps us narrow down the maybe list. So, right now, the honest answer is we've found thousands of exoplanets. We've found some that are Earth-size and in the habitable zones. But we do not yet know whether any of them are true picnic planets. Not because we're failing, because the universe is huge. Planets are far, and nature refuses to hand us the answer key.
Thank you so much for joining us on our adventure today.
I'm really glad you came along. Mom, can I say for our story?
Of course, next we're going to tackle the bigger question. If we find another Earth, how would we ever get there?